Good evening, everybody. A very warm welcome to today's session. How is everybody doing? I hope all of you are in the best of your spirits and is in the best of your health. Quickly let me know if I'm audible, if I'm visible. सब सुनाई दे रहा है? Are you able to hear me properly? जल्दी से good to go दो. All right, Navyat, Himanshu, hi Kumud, Mansi is here, Captain Jack Sparrow is here like always, Mansi, Himanshu, okay. Everything is fine, Navyat, thank you for letting me know. All right, thank you, Kumud. The agenda, like you guys know, hydrocarbons is the chapter pickup for the day. The chapter belongs to class 11th, but of course, when we talk about hydrocarbons, that's the very start when you start getting the flavor of organic chemistry. So till the GOC, it's like the tools and the instruments that you're using. जब तक जनरल ऑर्गेनिक केमिस्ट्री चल रहा है ऐसा लगता है कि बस हम डीकोड करने के तरीके ढूंढ रहे हैं. इलेक्ट्रॉन डिस्प्लेसमेंट इफेक्ट है, रेजोनेंस है, एसिडिक बेसिक बिहेवियर है. आपके पास सारी वो चीज़ें हैं जिससे हम डीकोड करते हैं. बट हाइड्रोकार्बन in the authentic sense is the very start of organic chemistry. Okay, so I am sure you guys are very excited for this very chapter, hydrocarbons. Agenda is simple. When I talk about hydrocarbons, guys, I am sure what all is striking in your mind. Let's see. Let me show it to you. Of course, carbon and hydrogen is striking your minds, right? So carbon, hydrogen, जहाँ दिखे that is hydrocarbons. So क्या वो आपको benzene में दिख सकता है? Yes, obviously in benzene you have what? Carbon and hydrogen, right? When we are talking about any kind of a cyclohexane, let's say, is it carbon, hydrogen? Yes, indeed. In fact, carbon's best friend in organic chemistry is hydrogen, right? So guys, make sure you understand hydrocarbon is the very start, okay? I've not understood inorganic. Will I be able to understand hydrocarbon? शुभम, कोई लिंक ही नहीं है, टेंशन नॉट, बिल्कुल समझ में आएगा. बस फोकस कर, ठीक है? साथ में जुड़ा रहे, एंड तक साथ में रहो. आज होगा थियोरिटिकल पोर्शन ऑफ हाइड्रोकार्बन्स, कल होगा इसके प्रीवियस ईयर क्वेश्चंस. दोनों सेशंस अटेंड करोगे, इट विल गिव यू अ बूस्ट, इट विल गिव यू अ लॉट ऑफ कॉन्फिडेंस. ऑलराइट, so with that, let me tell you what all do we have when we are talking about hydrocarbons. We have, यार हर्षदीप यार कैसी गल करदा पे है यार, है सिंह साहब. कितने टाइम की क्लास है? मैं टाइम वाइम सोच के तो नहीं आती हूँ, इतना तो आपको समझ में आ चुका होगा अभी तक. मैं कॉन्सेप्ट लेकर आती हूँ. जब तक खत्म नहीं होगा हाइड्रोकार्बन, मैं यही हूँ, चाहे जितना जल्दी हो जाए या जितना लेट हो, मैनू फर्क नहीं पड़ता. I am here till the very end and I expect you also to be here till the very end. This is my expectation and I hope that you will fulfill my expectation for sure. Right? So, अब time हटा दो दिमाग से, focus हो जाओ, be in the sync. Let's get started. Is it for advanced too? Of course, Ayushi, we are targeting 2022 with the advance, of course. Right? So, देख लीजिए, ये पूरा का पूरा road map है जो आपके सामने है. क्या है, क्या यहाँ पे आप देख सकते हैं, ए साइक्लिक सैचुरेटेड है, उसमें अनसैचुरेटेड है. सैचुरेटेड में एल्केन्स आता है, अनसैचुरेटेड में एल्कीन एंड एल्काइन आता है. साइक्लिक में साइक्लोहेक्सेन और एलिफैटिक, एनी काइंड ऑफ एलिफैटिक साइक्लोसिस्टम. whereas when we are talking about cyclic, there is also something called aromatic, which is very important, right? Because this is the very link for different kind of compounds that we will be forming going forward with the other chapters, right? अच्छा, अब आ जाइए यहाँ पे, ठीक है, और देखिए बहुत बारीकी से कि this is the classification which is very chapter specific. I have got a very chapter specific roadmap here. We are not talking about heterocyclic system because a heterocyclic system like let's say pyridine is not even a part of this particular chapter hydrocarbons, but it is a part of the hydrocarbons for sure and it will come in a heterocyclic system, right? ठीक है, तो अब भाई लोग शुरू हो जाते हैं। कैसे करने वाले हैं प्लीज देखिए, ठीक है। देवाशीष यार, नाम यहाँ पे नेम रिएक्शंस के आने वाले हैं बहुत सारे, इसलिए आई एम होपफुल everybody is ready with your mindfulness, everybody is ready with your notebook, everybody is ready with your participative skills, ठीक है। और शुरू करते हैं। वर्षा, मैं थोड़ा सा अर्जुना विजन के साथ चलना चाहूंगी। यहाँ पे हमारे पास ऐसे सवाल आए ना, व्हाट इज इंडक्टिव इफेक्ट, व्हाट इज रेजोनेंस, तो इधर उधर ही घूमते रह जाएंगे। जो एजेंडा लेकर आए हैं हम वो तो टच भी नहीं होगा, बिकॉज आपको पता है व्हेन इट इज अबाउट ऑर्गेनिक केमिस्ट्री तो बात चलती है तो दूर तक जाती है, तो बहुत दूर तक हमारे पास, दूर चलेंगे तो फिर पूरा ऑर्गेनिक केमिस्ट्री कंप्लीट हो जाएगा ना। तो बहुत ही सिस्टमैटिक तरीके से आज हम पढ़ने वाले हैं। I would also suggest you to be very systematic with me. Whatever doubts you have, keep it for the end. We'll try to address it at the very end. So be with me. Let's get started. Let me tell you how am I going to proceed is, guys, alkanes पढ़ेंगे पहले, फिर alkenes, फिर alkynes, फिर benzene. ये हमारा एजेंडा है आज का। That's it. अच्छा, एल्केन में क्या क्या पढ़ने वाले? प्रेपरेशन एंड द केमिकल प्रॉपर्टीज। एल्कीन में क्या पढ़ने वाले? प्रेपरेशन एंड द केमिकल प्रॉपर्टीज। एल्काइंस में क्या पढ़ने वाले हैं? प्रेपरेशन एंड द केमिकल प्रॉपर्टीज। और जब तक बेंजीन तक पहुंचेंगे ना, तो आप देखेंगे कि हमारे पास ऑलरेडी द मेथड्स फॉर द प्रेपरेशन ऑफ बेंजीन विल बी रेडी, एंड ऑल दैट वी विल बी डूइंग वुड बी द केमिकल प्रॉपर्टीज। ओके, नाउ I want you to write everything जो preparation chemical properties ये जितना भी हम करेंगे ना, if at the end of the session you can compile everything without watching it from your own mind, from your own brain, then that means you're good to go for hydrocarbons and the other chapters. So with that said, without now any further ado, let's get started. Preparation methods, guys, I'm doing for alkanes. We will be doing it from hydrocarbons, we will be doing it from alkyl halides, and we will be doing from carboxylic acids. Okay, so let's start with the hydrocarbons. How can we make alkane? क्या एजेंडा है? alkane बनाना है। कहाँ से बनाना है? हाइड्रोकार्बन से। सबसे पहले चमकना चाहिए alkynes. alkynes आप लीजिए, उसमें कैटालिटिक हाइड्रोजिनेशन कीजिए। हाउ डू यू कैरी आउट कैटालिटिक हाइड्रोजिनेशन? निकल, प्लैटिनम, पैलेडियम, द 3 favorite catalysts of any organic chemist for carrying out reduction. Nickel, platinum, palladium. In the presence of hydrogen, there will be catalytic hydrogenation, and what you end up getting will be alkane. ठीक है। तन्मय घोष, एरोमेटिक कंपाउंड्स अलग से नहीं होगा, ओनली द केमिकल प्रॉपर्टीज ऑफ बेंजीन होगा, ठीक है, जो कि बहुत ही सिंपल है, ठीक है। सो नाउ द नेक्स्ट थिंग इज कैटालिटिक हाइड्रोजिनेशन। अगर मैं बात करूं इस तरीके से, इफ आई टेक प्रोपाइन, आई विल एंड अप गेटिंग प्रोपेन, राइट। कैन आई यूज लिथियम एल्यूमिनियम हाइड्राइड? यस वी कैन, बट वी आर डूइंग इट वेरी वेरी सिस्टमैटिकली एंड डूइंग इट फ्रॉम द मोस्ट इंपॉर्टेंट reagents perspective, ठीक है। So lithium aluminum hydride can also be used, but when we are talking about catalytic hydrogenation, basically we are talking about nickel, platinum, palladium in the presence of hydrogen, and that's the first process to go about conversion of alkyne or alkene to alkane. If you're taking alkyne, take 2 moles of hydrogen. If you're taking alkene, take 1 mole of hydrogen. Then is alkyl halides. Now comes the first named reaction of the day, Wood's reaction. Also there is a named reaction, Sabatier-Sendrens. Anybody can tell me what is Sabatier-Sendrens reaction? Sabatier-Sendrens reaction. जल्दी से बताइए क्या होता है? Anybody has an idea? सिर्फ नाम है, देख लीजिए। इफ यू यूजिंग इन द कैटालिटिक हाइड्रोजिनेशन जस्ट द रेनी निकल, finely powdered nickel in the presence of hydrogen, we call it Sabatier-Sendrens reaction. नाम important नहीं है, काम important है. So remember the function of it, the work of it, rather than the name of it. Like Shakespeare once said, what's in a name? A lot is in the name. The named reactions are then in the name. So yes, but here the sentence, Sabatier sentence is not very much important from the name perspective, but from the work perspective it is very important. ठीक है? अच्छा, अब देख लीजिए alkyl halide Woods reaction coming your way, the favorite one of everybody of you. आप alkyl halide लेते हैं, sodium लेते हैं, another alkyl halide I'm taking as the same one. There is a problem if I take different alkyl halides. यहाँ पे आप देख लीजिए NaX निकल रहा है 2 मोल और RR, it is kind of a coupling which is happening. 2 R जुड़ जा रहे हैं. It's kind of 2 R's coupling together. The final product is having higher number of carbons as the starting material. Now the problem if I'm taking 2 different alkyl halides is, सारे के सारे उसको क्या पता यार, आप देख लीजिए. If for example I have a test tube and in this I have one of the Rx and the other one is R-X and I am adding to it sodium in the presence of dry ether, so of course there will be what? Woods reaction. Now how does Rx knows that it has to react with the R-X? Can it not react with its own self? And if it reacts with its own self, it will give you RR. Similarly, R-X को कैसे पता कि भाई मेरे को Rx के साथ ही रिएक्ट करना है? क्या वो खुद के साथ रिएक्ट नहीं कर सकता है? मतलब खुद जैसे एक अलग मॉलिक्यूल के साथ बिल्कुल कर सकता है, and will give you R-. And then comes a third possibility when they're reacting with each other and will give you R-. So what do you understand from here? When you're taking different alkyl halides, you guys will be getting, unlike what you're seeing here, if you're taking the same kind of alkyl halide, there's just one product which is forming, which is chill. Okay, very good. Observe that we are getting even number of carbons because odd plus odd is even, even plus even is also even. Like Tanmay is saying, 3 different products आएगा, बिल्कुल 3 different products आएगा, traces मिलेंगे, वो भी उनकी product की yield जो है, भाई, the time is about money. मॉडर्न एरा इज अबाउट मनी. पैसा चाहिए बॉस. और जब हम बात कर रहे हैं आज के टाइम की, मॉडर्न टाइम की, और एक ऐसी प्रोसेस जिसमें सोडियम यूज हो रहा है, यू आर पुटिंग हार्म टू द एनवायरमेंट ऑल्सो बिकॉज देयर विल बी फ्यूम्स कमिंग आउट एंड द फाइनल प्रोडक्ट इज बिल्कुल कम परसेंटेज यील्ड में आपको प्रोडक्ट्स मिल रहे हैं. हु केयर्स? हु हैज द टाइम एंड एनर्जी टू get the products in such small amounts? So here we get traces. That's why it's not a good method for the preparation of odd number of hydrocarbons. So if you have to make odd number of hydrocarbons, odd number of carbons in the hydrocarbon, I should say rather, if you want odd number of carbons, अगर मुझे 3 कार्बन चाहिए या 5 कार्बन चाहिए अपने प्रोडक्ट में, तो भाई वुड्स तो बिग नो. अगर हमें रेटिंग देनी होती ना इसको 5 स्टार में से, कितनी स्टार की रेटिंग देते यार वुड्स रिएक्शन को? सूर्या, जस्ट फॉर यू, इफ वी हैड टू गिव अ रेटिंग टू वुड्स रिएक्शन फॉर द प्रोडक्शन ऑफ ऑड कार्बन product having odd carbons, how much would you rate? How many stars? Use the stars and let me know. Varsha is being very kind. 4 star Captain Jack Sparrow. भाई तुम्हारा 18 मिनट में ऐसा लग रहा है खाना आ गया है. नहीं, इतना अच्छा स्टार मत दो. 1 star is what we will give probably because it's a very poor methods for the production of the odd carbons in our product. Why? Accountability. भाई कुछ तो accountability रखो यार. बहुत बुरा मेथड है ये odd carbons के लिए. Probably if you're giving 4 or 5, that's because for the even maybe we can give at least 3-4 stars, but not for odd carbon in our product. The reason is why? The reason is because we have very less yield coming. Not just very less yield coming, we are getting multiple products. What's the disadvantage, ma'am? ये तो एक तीर से 2 निशाने हो गए ना. To hit 2 in a bush for every English speaking person, to hit 2 in a bush. Why? Why is it not desirable? Because, to separate them is also a task. They have very close boiling points, so distillation will also be very ineffective. So that is overall going to take a lot of amount of energy of yours. That's why it's better to use the next method that I will be telling you. For example, soda lime process if we are taking. It's very simple. Soda lime process, everybody, you can see that. We have sodium hydroxide for which we are using the term soda. Of course, we are not using the lemon soda here. Soda lime से बच्चे को लगता है कि हाँ कुछ पीने वाली चीज यूज कर रहे हैं हम. भाई soda lime is of course not something that is it's something that you can drink, of course. It is sodium hydroxide, the dragon of chemistry, and calcium oxide. So you have lime here. So what you get is, think of it like this, just remove CO2. First you convert it into the sodium salt of the carboxylic acid, and then you add sodium, soda lime, basically NaOH plus calcium oxide. So what happens is remove CO2 and you end up getting RH, and what you have is, look at this, calcium is here, two of the oxygens are here, right? One oxygen is here, so calcium oxide plus CO2, can you understand? It is CO3. It's going to give you calcium carbonate. And calcium carbonate, of course, जब sodium सामने है, when sodium, the very reactive metal, is around, immediately it would want to, displace this calcium and will give you Na2CO3, sodium carbonate, as your final product. So sometimes books mention final product as calcium carbonate, but it further undergoes reaction with the sodium to finally give you sodium carbonate. Okay, ma'am, will we do previous year questions too? Manav Gupta, not today. It's tomorrow with Praveen sir at 7 o'clock. Right? Today, it's just about the theory. Only theory. Okay? ठीक है, for example, सोनू, एग्जाम्पल आपका, अगर आप CH3 ले लीजिए, एग्जाम्पल देख लीजिए. अगर मैं इस तरीके से लिख रही हूं, CH3COOH, do you understand? I can get CH4. Simply क्या करना है, अपने को बस कार्बन डाइऑक्साइड निकालना है from the hydrocarbon which is given, and you end up getting CH4. Shall we use that for short notes? Manav, please use this box method for the short notes. This is called box method. The easiest way to find out the final product. Your JEE examination is not a subjective paper. Knowing mechanisms of only handful of reactions is important. आप लोग क्या प्रॉब्लम है आप लोगों को कि आप हर एक का मैकेनिज्म में डूब जाते हैं, and when you get into the depth of every mechanism, you would be like, यार इतना सारा है, समझ नहीं आ रहा है, confusing है, क्या प्रोडक्ट बनेगा, कैसे पता चलेगा क्या प्रोडक्ट है, and then comes all sorts of questions that you keep asking me. So the answer to every kind of inhibition that you carry for organic chemistry is be systematic and be smart. The two S that is required, systematic and smart. That's it. जसवंत बिल्कुल यार, जसवंत कह रहे हैं डब्बा मेथड यही है, बॉक्स मेथड इज डब्बा मेथड, द आउट ऑफ बॉक्स मेथड. नाउ यू नो. ठीक है, ओके. नाउ let me tell you, Kolbe's electrolysis method is also a wonderful method where again what you end up getting is even number of carbons as your final product. क्यों, क्या हो रहा है यहाँ पे? इलेक्ट्रोलिसिस हो रहा है. कोल्बे में क्या होबे? इलेक्ट्रोलिसिस होबे. इलेक्ट्रोलिसिस में क्या होबे? R और R combine होबे. And when R and R combine होबे, तो what you get is, of course, odd plus odd is also even, and even plus even is also even. So what you get is R. ये मानव ऐसी बातें करी ना, मतलब स्क्रीन से निकल कर आ सकते हैं एक दो. ठीक है, ऐसे सरेंडर वरेंडर वाली कोई बातें नहीं करनी है यहाँ पे. Remove these words from the dictionary. You cannot score good without organic chemistry being on your side. Don't forget that. If you're aspiring to be having a great marks in your mains, and if you want to clear advanced, not possible without organic chemistry. You would have to have it with the great marks, then only you will come out with flying colors. आज पहले ही बता दे रही हूं मैं, तो ये गलती गुस्ताखी सरेंडर वाली नहीं कर सकते हैं आप लोग, ठीक है? सो अच्युत, क्या बात है यार, ऑर्गेनिक स्ट्रॉन्गेस्ट है मेरी, बढ़िया, ये सुनकर अच्छा लगा. तो ये बता दो भाई, कैन वी प्रिपेयर मीथेन बाय कोल बेस्ड इलेक्ट्रोलिसिस, यस और नो, व्हाट डू यू थिंक? मिश्रा साहब आप ही बताओ, आस्क एनीथिंग. कैन वी प्रिपेयर मीथेन बाय कोल बेस्ड इलेक्ट्रोलिसिस? No, of course, that's absolutely right. No is the answer. तो भाई organic सबसे strong है, वो तो समझ में आ गया हमें. The answer is no here. So now let's enter chemical properties. No क्यों है ये समझ में आ गया ना? क्योंकि भाई लोग हमारे पास यहाँ पे हमेशा कंडेंस होने वाले हैं 2 R. तो अगर मैं एक CH3COOH से स्टार्ट कर रही हूं, पहले तो इसका सोडियम सॉल्ट ले लीजिए, CH3COONA. And if you're reacting, if you're doing electrolysis, 2 moles of sodium acetate will finally give you ethane. So what is the smallest hydrocarbon possible from coal-based electrolysis? The answer is ethane, not methane. Methane is not possible. Single carbon product is not possible, like Raj said. Single carbon can't be produced, right? Is the mechanism important? Tanmay Ghosh, no, not for this one, right? I will ensure that I conduct a session where every important mechanism is taken up. Today is not a day of mechanisms. Today is a day of hydrocarbons in the whole nutshell, satellite vision, the bird view, the godly view. And once you attain it, you certainly will feel confident. I'll let you know where mechanism is something that you must keep in your mind. Okay? Now let's proceed and talk about the chemical properties of alkanes. बच्चा बच्चा जानता है alkane का एक और नाम है. क्या नाम है? What are alkanes better known as? एल्केन का क्या एक और नाम है? तो संतोष बता दे यार, नया है तो जल्दी से देखते हैं कि कितना मजा आ रहा है आपको. एल्केन्स का एक और नाम है. Absolutely, Chotu Mishra is absolutely right. Radhika Mittal is right. Paraffin, they have paraffin. They have less affinity. They are less reactive. They're very less reactive. They are saksham, satisfied with the kind of bonds they're forming. Carbon making 4 bonds with the hydrogen, or carbon and a carbon bond. All of them are strong bonds. It doesn't require, there's no electronegativity difference as such between the 2 carbons. So do you understand that it doesn't want to react? And that's why the kind of reactions that you're going to observe are the simplest one possible. Like there will be substitution wherein आप क्या कर सकते हैं, आपको डालना पड़ेगा H nu देना पड़ेगा, सनलाइट देना पड़ेगा, आपको रेडिएशन प्रोवाइड करनी पड़ेगी, so that you can carry out halogenation. So substitution, when I talk about, yes, the hydrogen can be replaced. It's very difficult to replace it. It happens via free radical mechanism, like in the case of this particular methane undergoing chlorination to give you CH3Cl. It is done via free radical mechanism. When I talk about free radical mechanism, there are 3 steps involved. What are the 3 steps? Number 1, chain initiation. हमेशा मैं इसको कोविड वायरस की तरह समझाती हूं कि जैसे इनिशिएट हुआ, बैट से इंसान में आया, फ्रॉम अ बैट the virus came to the first human. That first human was, the first infected human is the initiation reaction. After initiation, now the person was not following social protocols, social distancing, कोई मास्क नहीं, कोई 6 feet की दूरी नहीं, nothing at all. So what happened? Propagation. And finally, vaccines are here. Variants like Omicron, which is spreading like rapid fire, and everybody is getting infected. This is probably going to lead to termination. So like Jaswant has said, chain initiation, chain propagation, and chain termination. All three of them are the steps which are involved when we are talking about a reaction that you're able to observe. Okay? So now if I talk about combustion, this is the one that all my lions out there know very well. Combustion तो आप सभी जानते ही हैं. कहाँ पढ़ चुके हैं? Some basic concepts में पढ़ चुके हैं. Enthalpy of combustion when we were talking about in thermodynamics. So everybody knows, I'm not even going to balance it. Everybody knows that if we are taking a hydrocarbon, we are heating it in the presence of oxygen, we're going to get carbon dioxide and H2O and heat. ठीक है? अच्छा, अब controlled oxidation की बात करें. Controlled oxidation, the process of heating the substance with a regulated supply of oxygen or air at high pressure in the presence of catalyst to produce various oxidation products. Now let me tell you guys, the same kind of a thing can be, the three reactions are always asked in different ways by the examiner. देख लीजिए इसको. ठीक है, आप देख लीजिए, कॉपर अगर यूज कर रहे हैं, you're ending up getting an alcohol. If you're using, let's say, the same reactant but molybdenum oxide, you are ending up getting methanol. And if guys you're using ethane, you're ending up getting finally ethanoic acid. Please observe. ठीक है? Observe this. Copper की presence में methanol, ठीक है? Molybdenum oxide, methane ही है, but methanol. But ethane in the presence of manganese acetate, you are ending up getting acid. Which of the following reactions is shown by hydrocarbon alkane? So ऐसा direct सवाल आता है, ये पूरा NCERT से control C control V है. This is there's no explanation to it. We are doing controlled oxidation. You can see that addition of oxygen is oxidation. So here oxygen is coming in your product at all the places. So oxidation. Why is this variation? Because of the different catalysts that we are using and because of the different oxygen supply that we are providing. Oxygen की supply अगर आप बदलते रहोगे तो अलग अलग product मिल रहा है आपको. In the presence of a suitable catalyst. इसमें क्या कर सकते हैं? As it is याद करना है. Okay? Oxidation, controlled oxidation. Now comes the most important one. This is also one of the things that we will be talking about for the preparation of benzene. If you start with hexane, आप hexane ले लीजिए और कोई भी ऑक्साइड ले लीजिए, molybdenum का ऑक्साइड ले लीजिए, vanadium का ऑक्साइड ले लीजिए या फिर chromium का ऑक्साइड. So you can take all of these, right? You can take manganese oxide, chromium oxide, vanadium oxide, and you will end up getting our very own benzene. Observe. Final reaction is this. Please see. N-hexane in the presence of alumina, very high temperatures, very high pressure conditions. In the presence of chromium oxide, vanadium oxide, molybdenum oxide is giving benzene. So can we make benzene, the aromatic hydrocarbon, starting from alkane? Yes, we can. What alkane to take? N-hexane. The very first one that you must know for the preparation. Right? ठीक है? चलो बहुत बहुत शुक्रिया कुमुद. अब साथ जुड़े रहो क्योंकि अब हम स्टार्ट कर रहे हैं एल्कीन. So guys, all of those students who are interested in making short notes, do understand how to make short notes from the sessions that we have till whatever we have done in today's session. Please understand. Preparation किया हमने. First from alkanes किया, जहां पे हमने बात करी production of alkane, starting with इस तरीके से hydrocarbons like alkenes or alkynes and doing the catalytic hydrogenation. द मोस्ट इंपॉर्टेंट वन. फिर हमने बात करा वुड्स का, दैट मीन्स फ्रॉम एल्काइल हेलाइड. एंड थर्ड हमने बात किया फ्रॉम कार्बोक्सिलिक एसिड, जिसमें हमने बात करी सोडा लाइम की. एंड वी हैव टॉक्ड अबाउट कोलवे. So two of the named reactions are already done. Can we get PDF of this class? No, I am deliberately not going to give you PDF of today's session. I want you to do it yourself, write it yourself. Because this is anyhow the bird vision, the bird view that we are giving you. ये खुद नहीं लिखोगे तो काम नहीं चलेगा, फिर फायदा ही क्या है. ठीक है. अच्छा, फिर हमने बात करी केमिकल प्रॉपर्टीज की. केमिकल प्रॉपर्टीज में हमने बहुत सिंपल फर्स्ट सब्स्टिट्यूशन, जहां पे हैलोजिनेशन पढ़ा हमने वाया फ्री रेडिकल मैकेनिज्म. नंबर 2 हमने बात कर ली भाई ऑक्सीडेशन, जहां पे 3 फैक्चुअल रिएक्शंस थी, जहां पे अल्कोहल मिल रहा था, हमारे पास फॉर्मेल्डिहाइड मिल रहा था और इथेनोइक एसिड मिल रहा था. थर्ड हमने बात करी कंबशन. और फोर्थ हमने बात कर ली द रिएक्शंस वेयर व्हाट डू वी हैव इज this kind of aromatization happening, benzene formation happening. If you know it systematically, see how well you would understand. ठीक है, ठीक है. बहुत बहुत शुक्रिया यादव. साहिल बस कंट्रोल योर इमोशंस बाबा. आओ अब यहाँ पे और पढ़ते हैं प्रेपरेशन ऑफ एल्कीन्स नाउ फ्रॉम एल्काइन्स एंड अल्कोहल्स. ठीक है. एल्काइंस की बात करें बच्चा लोग तो कैसे हम बना सकते हैं, 2 चीजें याद होनी चाहिए. राजपूत फॉर श्योर. 2 things that you must remember here. If we are starting with alkyne, LCBT. Everybody knows LGBT, right? Here what do we have? LCBT. Lindlar catalyst will give you cis product. Birch catalyst will give you trans. This is the trick to remember and to ace questions like these. Lindlar, cis product is what you get if there is a possibility of cis formation. If you're starting with ethyne, then there is nothing called cis and trans. The geometrical isomerism will come into existence only when you are dealing with a particular non-terminal alkyne, right? So guys, here Lindlar, cis, birch, trans. So you can see that if I have RC triple bond CR, let me take its specific example right here. You can take here CH3C triple bond C CH3. You can see that I get CH3 on same side. CH3 on same side. That means it's going to be cis. And CH3 on opposite sides, that means it's going to be trans. So remember LCBT. Okay? Now guys, let's make the alkenes from what? From alcohols. So you can see that alcohol, you're doing dehydration basically in the acidic medium. Okay? What you end up getting, देखिए alcohol, OH is not a good leaving group. Not a good leaving group. It's easily नहीं निकलता है, but when H plus attacks this oxygen, and what you have, or I should rather say, because the attack is always shown from rich to poor. So oxygen with the lone pair when attacks the H plus, oxygen will be making 3 bonds and a plus comes over oxygen. So now water is a very good leaving group. So this can easily leave and will give you a carbocation. Easily the carbocation can be formed. SN1 should knock the doors of your mind. SN1 will be dealing with separately also when I'll be dealing with all important reaction mechanism. So the moment you see carbocation coming in, SN1 or SN2 must be striking. So here it's SN1 happening. Okay. If we have to do a substitution. But E1 and E2 must strike the doors of your mind, for which both 3 degree is going to be most favorable. Here we have a 2 degree. So E1 mechanism is something that we can think of if the medium that we are providing is a polar protic solvent. So here, yes, the dehydration of alcohol, the mechanism is important So revise this. I will pick it up somewhere, sometime later when I will be talking about SN1, SN2, E1, E2 all together. So here dehydration of alcohol की बात करें तो देखिए कार्बोकेटाइन बन गया, मतलब E1 mechanism is something that is striking the doors of our mind. Carbocation formation, right? बिल्कुल Jack Sparrow, that's what I said. बिल्कुल 100%, don't worry. ठीक है. Now if I have a carbocation, अब क्या करना है? OH is gone. OH, the oxygen has attached the H plus. Water बना, water निकल लिया. अपने को बस पानी निकालना है. H2O is out. Then we have a carbocation coming in. Raj, it is E1 because the moment carbocation comes, E1 should knock the doors of your mind. ठीक है? So आशीष, भूल जाओ. Polar protic अभी भूल जाओ. फोकस. मैंने बताया कि यहां से ना हम पोलर प्रोटिक की बात शुरू कर सकते हैं. पोलर प्रोटिक की बात शुरू हुई तो फिर H प्लस निकलेगा. H प्लस निकलेगा तो फिर SN1, SN2, E1, E2 सभी आ जाएंगे. फिर इनके बारे में चर्चा शुरू होगी तो जो टॉपिक लेकर आए हैं उसकी तो डिस्कशन होगी नहीं, इसी की बात हम करते रहेंगे. इसलिए मैंने ये बोल दिया है कि आपके पास इसके लिए एक अलग सेशन दिया जाएगा. अभी है हाइड्रोकार्बन की बात, और जैसे ही हमारे पास इस तरीके का कार्बोकेटायन आ रहा है, दो पॉसिबिलिटीज आ जाती हैं. कार्बोकेटायन का अल्फा हाइड्रोजन, कार्बोकेटायन से अल्फा हाइड्रोजन को ढूंढो. व्हाट इज एन अल्फा हाइड्रोजन? द कार्बन विच इज जस्ट एडजेसेंट टू द कार्बन विद अ प्लस, द कार्बोकेटायन. And we have two such possibilities that I've marked as A and B. So I want you to think of which elimination, which hydrogen elimination will take place, A or B. Amya is asking, ma'am, please tell me a solution. I find very difficult hydrocarbon chapter. What to do? First of all, remove the term difficult from the dictionary of your life. Second, take things positively. Third, start doing the actions rather than speaking about it. Fourth, make the notes the way I'm asking you to. Fifth, be very attentive and be in sync with me, be in resonance with me. That's it. Hanji, kahe ko, B kahe ko? Everybody of you who is saying B, can you help me? Why B? What are you applying? किस बाबा को याद कर रहे हो आप? काहे को? बी काहे को? हाइपर कॉन्जुगेशन. भाई देखो क्या बना रहे हैं हम. एल्कीन एजेंडा था ना, भूल गए हो क्या? एजेंडा क्या था? यही होता है, हम ये भूल जाते हैं कि वाई वी आर टॉकिंग अबाउट व्हाट वी आर टॉकिंग अबाउट. बात स्टार्ट कर देते हैं. यही हो रहा है हर जगह, यही हो रहा है. टॉपिक होता है चलो अनएम्प्लॉयमेंट के बारे में आज बात करेंगे, और घूम कर वो कोई और ही कहानी स्टार्ट हो जाती है. तो जो टॉपिक है वो तो दिमाग में रखो ना. वी आर मेकिंग एल्कीन्स, वी आर डूइंग द प्रेपरेशन ऑफ एल्कीन्स. So we started with an alcohol. We said dehydration, मतलब अपने को बस पानी निकालना है. Dehydration means removal of water. So once water has been removed, we are getting a carbocation. But alkene is still not ready. It will only be ready once hydrogen, the alpha hydrogen, eliminates. And how will alpha hydrogen be? Which alpha hydrogen will be eliminated? Either this is the possibility. If this goes, this is what you get. And if the B goes, this is what you get. So which is more stable, A or B? Which is a more stable alkene? Which is a more stable alkene? I do not care about this carbocation. Okay, I know there is hyperconjugation. It has more alpha hydrogen. I know that this has inductive effect. It's okay, I know that. But I'm asking which is more stable alkene, because that's the agenda. B is any day stable, like Harshit, Mansi, Vamsi, Dilip is saying, everybody of you is saying B is stable. Why? That's what I'm asking. Question तो समझो मैं पूछ क्या रही हूं. क्यों है stable? क्या लगा रहे हो? किस बाबा को याद कर रहे हो? Is this some concept that you're applying or you're doing akkad bakkad Bombay bo? What is it? More substituted alkene is predominant. Jaswant, bilkul sahi. But there is something that we call this more substituted alkene is more stable. It's a concept. What concept? Which rule? किसको याद किया जब आपने बोला more substituted alkene is more stable? Of course, this is more substituted. Look at this. Here we have one methyl. Here we have one methyl. Here we have just ethyl. Here we have just hydrogen. So this is more substituted. You're right. And generally more substituted. Yes, finally. Thank you. Very good. So Vijay Kumar now is telling me Sedzef rule. Venkateshwar Cute is also telling me Sedzef. Jaswant now is telling me Sedzef. Vijay Kumar Sedzef. Now you guys are talking about the right concept. Varsha, it's not Markovnikov rule. Please keep the Markovnikov Baba off from here. Sedzef बाबा को याद कर लिया जाए बच्चा लोग तो आपको पता है कि अगर हम दो पॉसिबिलिटीज की बात करें we can end up getting but1ene and but2ene. And you only said, Varsha, Manav, everybody of you who is saying Markovnikov rule, it's not Markovnikov rule that we are applying here, it's the Sedzef rule that we are applying here. I'll talk about what Markovnikov rule is in a while. Sedzef rule says that the most substituted alkene would be the most preferred one. Kyun, kahe ko? Hyperconjugation is what you can think of. C double bond C, CH3 is here, CH3 is here. So you can see that more number of alpha hydrogens are here around this group of interest, 6 alpha hydrogen. But when I'm talking about but1ene, I have just 2 alpha hydrogens. Right? So more substituted alkene is more stable as per the Sedzef rule. Okay? Now it's a story for another day that's a story for alcohol, phenols and ether, that why then is a non-substituted alkene or less stable substituted alkene, I should rather say, why is that even forming? If ideally the Sedzef product, more substituted one should be predominant. We'll talk about it later, but then the right questions must strike at the right time. So, Mr. Nobody, I hope it is clear what Sedzef rule is. This is what is Sedzef rule. Padh lo bhai log. More substituted alkene is predominant because it's generally more stable. ठीक है? यादव यार कोई ऐसी कहानी मत बनाओ. Less number of hydrogen, ये Markovnikov rule नहीं है. We are not talking about Markovnikov rule. We are talking about Sedzef rule where it is about the substituted alkene which is going to be more stable, right? Now, hence, everybody, like you already told me, but2ene should be relatively more stable and more major, should be the major product as compared to but1ene, right? So, elimination किसका होगा? ये वाला, B वाले जो hydrogens marked हैं, these will undergo alpha elimination or beta elimination. We call them beta elimination. साथ वाला carbon का elimination. Alpha elimination is only possible when we are making carbenes, for example. Okay? Well, now let's enter the chemical properties of alkene where we have to talk about addition, oxidation, ozonolysis and polymerization. ठीक है? So addition reaction की जब हम बात करें तो addition of HBr to a symmetrical alkene, now all of you were thinking of, आप याद कर रहे थे ना Markovnikov बाबा को? Many of you thought of Markovnikov rule when it was about the Sedzef rule. So do remember when we are talking about elimination, the rule to be applied is the Sedzef rule. Of course, terms and conditions applied. There are specific cases where a non-substituted or less substituted alkene is the major product, I should say. ठीक है? There are very specific cases. Maybe the base is humongous. Base बहुत बड़ा है, उसके पास option नहीं है एक ऐसा प्रोटॉन एब्स्ट्रैक्ट करने का जो कि समवेयर इनसाइड द रिंग, समवेयर इनसाइड द चेन है, तो वो बाहर वाले हाइड्रोजन में ही खुश है ना? तो बहुत स्पेसिफिक केसेस है, अदरवाइज सेट-सेफ रूल इज द वन दैट शुड बी रेडिली इन्वोकेबल बाय यू गाइज. Now coming to questions like this where addition is happening, Markovnikov rule should be striking the doors of your mind. ठीक है? So when we have HBr, we have out here addition of HBr to an unsymmetrical alkene. देख लीजिए क्या हो रहा है. दो possibilities आ रही है. We have two possibilities here. One possibility is one bromopropane, the other possibility is two bromopropane. जल्दी से मुझे बता दीजिए A या B, which is going to be the major product. A or B. And now which rule are you guys applying? Knock knock, which rule? Now you are absolutely right, Captain Jack Sparrow. Markovnikov rule. Yes, just one Markovnikov rule. Sedzev, Rakesh Kumar, स्क्रीन से ही निकलकर एक बड़ी जोर की आएगा. हाँ, गलत आंसर्स नहीं देने हैं. प्लीज बी माइंडफुल. पढ़ने के लिए आए हो तो ध्यान से पढ़िए. वी आर स्पेयरिंग आउट टाइम फॉर यू गाइज फॉर अ पर्पस. सो प्लीज मेक श्योर you're listening to what I'm teaching carefully, otherwise there's no point of me. I can just wrap around. मैं बहुत दिल से पढ़ाती हूँ, मैं आपको सच बता रही हूँ. और कोई मजा नहीं है अगर इस तरीके से उल्टे फुल्टे आंसर्स अगर आप देंगे तो. It is very easy for me to just, I have slides out here, एक एक करके I can just say a tata bye bye and go. Nobody would say a word. But I want to make an impact. I want to make a difference. So please make sure you are mindful there and be in the sync with me. So now coming back to this, yes, Markovnikov बाबा याद आने चाहिए हमें. मेजर प्रोडक्ट क्योंकि यहीं से आता है. और क्यों आने चाहिए, क्या कहता है Markovnikov रूल? एडिशन जब कर रहे हैं हम, so when we are talking about adding molecule, जिसका दूसरा नाम है addendum. Addendum is what? An adding molecule. Like in this case, we were adding HBr. Always the adding molecule that we have, we can always make one part of it as a delta plus and the other part of it as delta minus. The one which is more electronegative will be a delta minus, and the one which is relatively less electronegative, we will put a delta plus. And chemistry is all about opposite attracts. So basically what Markovnikov rule is going to follow is हमेशा एक ऐसा कार्बोकेटायन बन रहा है जो कि stable कार्बोकेटायन है, right? And to the stable one, what is going to be happening? So there are two possibilities of the carbocation. One is this particular carbocation, the other one is this particular carbocation. And if you see very closely here, the first carbocation has more number of alpha hydrogens, 6 alpha hydrogens. The other one has only 2 alpha hydrogens. Here we have 2 plus I effect. Here we have just 1 plus I effect. No doubts about it that the first one is more stable as compared to the second one. So the negative part, the chemistry is all about opposite attracts. Anybody who is not able to understand what product will be formed, you're not properly attracting the opposites. That's it. If you know where the plus will be, and everybody already has a fair sense of electronegativity, you know that bromine is more electronegative as compared to hydrogen. If we have a carbocation carbon with a plus, do you understand delta minus bromine के ऊपर है तो bromine कहाँ लगेगा? Plus के साथ ही तो लगेगा, opposite attract. So this is what that the product should be formed. So basically Markovnikov rule follows a pathway of carbocation, but the NCERT definition, guys, is this. Negative part of the addendum gets attached to that doubly bonded carbon which possesses lesser number of hydrogen atoms. Let's go back and see once again. So you have this particular alkene out here. this doubly bonded carbon, the focus should be on the doubly bonded carbons. One doubly bonded carbon is this, two hydrogens are here. The other doubly bonded carbon is this, one hydrogen is here. The negative part of the addendum, like in our case it was HBr. Br is the negative part of the adding molecule. It will attach where? To that particular carbon which has less number of hydrogens. So this particular carbon, hence this will be the major product, the second one, like all of you were saying. Right? So Markovnikov rule, please note that it is nothing but the negative part of the addendum gets attached to that doubly bonded carbon which possesses lesser number of hydrogen. Right? So hence the major and minor is what you can decode. Cool? Now guys, let's enter the oxidation part where all of you were missing KMnO4. बहुत time से KMnO4 को miss कर रहे थे. KMnO4 किसके साथ है? संगति का असर. ये आपके लिए भी है. अगर आपकी संगति स्पैमर्स की है ना तो अपनी संगति जरा सुधार लीजिए. Because लॉन्ग रन में मेरी बात आपको जरूर याद आएगी इस चीज को लेकर. The people you're surrounded with plays the major role in your life, how your life is going to be. So surround yourself with people better than you for sure, not worse than you. So here the Sangati, what is the surrounding species? Like, is it alkaline cold or is it the acidic medium that we are providing will make all the difference. For example, if you're just taking alkaline cold dilute KMnO4, you're still taking KMnO4. KMnO4 has manganese, which is in +7 oxidation state. The only option manganese +7 has is to go to a lower oxidation state. That means that if it itself undergoes reduction, will oxidize others, hence will act like an oxidizing agent. But what kind of an oxidizing agent it will be? Will it be making a diol? A vicinal diol? Or will it be making acids or aldehydes or ketones? Let's find out. Who plays the role? The people you're surrounded with. The people KMnO4 is surrounded with. ठीक है, तो ऑक्सीडेशन है तो आप जल्दी बताओ. क्लियर? Very good. I'm so impressed by you guys. Very nice. The kind of people that you're surrounded with, make sure you keep them better. So it is not my job out here to keep the momentum that you people are setting for the session right. I give the responsibility to you guys. Responsibility is ability to respond. And I give the ability to respond to you guys. The onus is upon you guys what kind of environment you want to create. So coming back to now the Bayer's reagent that we are talking about, we get guys diol. Okay? So we are starting with ethene. We are doing oxidation. We are adding dilute KMnO4. What we end up getting is diol. Cold dilute KMnO4. You can see diol is what you get. Cold, ab dekh lijiye, it is less than, it is a 0 degrees Celsius that we are maintaining here, or it can be the negative temperatures also. But the moment I am talking about acidic medium, it is not going to give us diol. Further oxidation will take place. So let me tell you, this diol, the two OH should be on the same side. Okay, this is on the same side. That's why we are calling it syn addition. Syn addition. That means the two OH are supposed to be on the same side. So when you're adding KMnO4, what you get? Syn addition. This is one of the ways to distinguish alkane from an alkene. Okay? Up next is acidic KMnO4 or acidic K2Cr2O7. When we are taking alkene, add KMnO4 or K2Cr2O7 in the presence of acidic medium, guys, there is a trick. The trick is break it. like you do in ozonolysis, and oxidize it. Okay, oxidize it. If you're getting ketones are not easily oxidized further. So ketone will be as it is. Ketone अगर मिल रहा है, do not oxidize it further. अच्छा, अगर आपके पास formaldehyde है, if you have formaldehyde converted into carbon dioxide, final product will be carbon dioxide. But if you have any other aldehyde coming, converted into acid, because aldehydes can easily be further oxidized to acids. It's just that think of formaldehyde like this, that you have here OH and OH and then remove H2O once again such that you end up getting carbon dioxide. So finally formaldehyde will give you carbon dioxide, otherwise any other aldehyde will give you acid. Okay, now let's take a specific example. Look at this. If I further do the oxidation, do you understand? I will get CH3 C double bond OH. Here also CH3 CHO and CH3 CHO, both are the same aldehydes that I am getting. Like I said, aldehydes can further be oxidized to acid, so oxidize them further thanks to the strong oxidizing agent KMNO4 that we have. Right? CH3 COOH, CH3 COOH, right? Now let's proceed. Do the ozonolysis. Ozonolysis जो अभी हमने double bond को तोड़ा, break the double bond. Keep your axes ready here because this is the simplest one. It proceeds via this particular intermediate ozonide. Ozonide मिलेगा finally. आप तोड़िए, इस तरीके से एक एसीटोन मिल गया, यहाँ पे भी ऑक्सीजन लगाइए, तोड़िए और ऑक्सीजन जोड़िए. The slogan here is simple. Break the double bond, insert oxygens, and you will end up your product. So what you end up getting is acetone here and formaldehyde here. Now let's proceed. Get our axis, break it. What you end up getting, you can see you will end up getting oxygen लगा दीजिए at the place of the double bond and you're good to go. Right? Now let's proceed and talk about polymerization, guys. If I talk about the famous polymer, polythene is the one that must strike the doors of your mind. There are two types of polythene, low density polythene and high density polythene. So if there is branching coming up in this kind of a polymerization, you get low density polythene. But if there is no branching, it's linear, then you get high density polythene. So there can be conglomeration of this particular chapter with the polymers chapter, which is the most underrated chapter. So connect the dots. Okay, now let's enter alkyne का zone. Alkynes में देख लीजिए preparation calcium carbide, vicinal dihalide, Kolbe electrolysis, three of them. This calcium carbide is the one that we use for the ripening of mango. The same reaction you study in S block. The same you study in biology. What we have is, if I'm talking about metal carbide like calcium carbide, what we end up getting is ethyne, CH triple bond CH. So guys, it's an industrial method. क्या करते हैं, देखिए मैंगोज जो हैं तोड़े जाते हैं और when they are not ripened, when they are in the green state only, not in the ripened state, then only we pick up, because it has to go from one place to another. Let's say from Karnataka it has to go to Arunachal Pradesh. It has to travel long distances. So if we are plucking the mangoes when they are in the ripened state, क्या होगा? जब तक it will reach the destination, it will be all ruined, right? So it is plucked out in a non-ripened state and finally ripened with the help of this ethyne gas. तो calcium carbide के एक powder होता है. This powder is kept in that particular जो भी जिस भी box में आपने mangoes रखे हुए हैं, there is of course moisture, so there is this reaction that happens and what you end up getting is ethyne, right? Is it good for health? Not at all. Should we go organic when it comes to eating mangoes? Of course, go organic. How to ensure that? Make sure you eat the mangoes which are not ripened because of this calcium carbide. ठीक है, तो प्रशांत हेल्थ के लिए सही नहीं रहता है जैसे मैंने बताया, तो याद रखिएगा इथाइन निकल रहा है कैल्शियम कार्बाइड से आफ्टर रिएक्टिंग विद द मॉइस्चर और वाटर. ओके, नाउ फॉर द विसिनल डाइहैलाइड गाइस, लेट्स सी इफ यू हैव दिस काइंड ऑफ अ विसिनल, बोले तो विसिनिटी, बगल वाले कार्बन पे भी होना चाहिए एक हैलोजन. ठीक है, सो आप देखिए यहाँ पे हमारे पास Br है, पहले अल्कोहल है, QH डाला, इट विल रिमूव HBr. लेट्स रिमूव HBr so that one of the bromines is left, which we can take care of by sodamide. This is sodamide. NaNH2. It will further remove another HBr, so 2 moles of HBr is removed, and finally what you end up getting is ethyne once again. Okay, the third one is the coal-based electrolysis method. Coal-based electrolysis, what you did for the preparation of alkane. How did we do the preparation of alkane? Coal-based में क्या हो बे? क्या हो बे? Everybody, coal-based में what we were taking was CH3COO minus Na plus, let's say, if this is the sodium salt of the carboxylic acid that I'm taking, right? हाँ, Manav Gupta is asking me, ma'am, why we didn't use KOH in the second step? Because after you have an alkene, na, it is not easy for KOH to remove another molecule of HBr. Okay, so KOH can only remove when we have carbon-carbon bond. The moment carbon double bond carbon comes, removal of HBr is not an easy task by any kind of a base like, let's say, alcoholic KOH. Hence, a stronger one is required. Who better than the sodamide? This is stronger as compared to KOH and will immediately help us in removing another molecule of HBr. Okay? What's happening? Beta elimination. 2 times beta elimination is happening. Students simply remove Br2 and make alkene. No, that's not the case. Okay? First, one more molecule of HBr is removed and then the other molecule of HBr is removed. Okay, now let's proceed and talk about the coal-based electrolysis here. When we were taking CH3COO minus Na plus, we were getting CH3CH3. Here, look at this. If I am taking potassium maleate, malic acid, everybody knows already. COOH here, COOH here. This kind of a cis form is malic acid. I'm removing the H plus and making it as a potassium salt of the malic acid. So what will happen on the electrolysis is, think of the carbon dioxide gone and a bond formed between the 2 carbons such that ethyne, or what we call it acetylene, is formed. Okay. पीयूष इसलिए कहते हैं टाइम से आइए. The mechanism, like Vijay Kumar said, is a free radical mechanism. It's electrolysis that is happening. Okay. Now let's enter the chemical properties of alkyne. Very simple ones. What is trans with 2COOH? So fumaric. अच्छा, एक और important बात लक्ष्य ने बातों में कह दी है. अगर हमारे पास fumaric होता, fumaric acid, which is the trans form of the same kind of an acid, just a trans form. Now here also, if I replace the 2 hydrogens with, let's say, potassium or sodium, doesn't matter, then also you will end up getting acetylene, no difference at all. Okay. Now let's move further, talk about the alkynes, addition, ozonolysis, polymerization. When we are talking about addition, very important, Kucherov. The name is not in NCERT. The name is not there, but the reaction is there. And let me tell you, this is JEE's favorite reaction. Trust me on this. You pick up the previous year questions and you would see this particular reaction repeating itself. What I've seen is students taking Ag, the moment you look at Ag2+, you think of mercuration, oxymercuration, demercuration. There's no such oxymercuration, demercuration happening here. We're just taking, let's say, HgSO4, mercury sulfate, mercuric sulfate with H2SO4. And all that you have to think of happening here also, yes, we have a cyclic intermediate which is formed. Carbon, carbon is तरीके से with the Ag plus this kind of a cyclic non-classical carbocation is formed here. But we are not getting into mechanism like I said. So think of Kucherov reaction very simply, guys, as addition of water as per Markovnikov rule. As per Markovnikov rule. That means Markovnikov ने क्या कहा? Addendum, the negative part of the addendum will be OH minus. The positive part of the addendum is H plus. Addendum is what? Adding molecule. The negative part of the addendum is what? OH minus. OH minus किस पे लगेगा? To that particular carbon of the doubly bonded carbons which has less number of hydrogen. So here we have triply bonded system. So guys, here what do we have? One hydrogen here and zero hydrogen here. So think of water getting added as per Markovnikov rule here. So OH will be added to this particular carbon. So we end up getting this. And the moment you see ene, can you see a double bond? Ene and all. Of course, you will do tautomerization so that you end up getting propanol here. Okay? Now, I want you guys to be very careful the moment you get Ag2 plus in the presence of H plus with an alkyne. Kucherov reaction is what is coming. Okay? Now, let's proceed further. Let's see ozonolysis. Ozonolysis with the triply bonded system is very easy. Break one of the double bonds. एक double bond को तोड़िए and what you put is double bond here oxygen, double bond here oxygen. So you end up getting diones. A diketone is what you get. If you are doing this kind of reduction, but if you further do H2O, if you add in the presence of H plus, that means you do hydrolysis. What you can do is break it, put OH here and OH here, break the carbon-carbon bond and make it into the respective acids. ओजोनोलिसिस तो यार लक्ष्य सबसे इजी होता है यार, है ना? क्यों? कार्बन डबल बॉन्ड कार्बन, break the double bond, put the oxygens. That's it. That's all that you have to do. It takes place via formation of ozonide. This is also a potential question that you must be aware of. What is the intermediate formed in ozonolysis? Ozonide. So these are few potential questions. When do we do tautomerism? Beena will do GOC once again, though we have taken up GOC some time back, but yes, we'll do tautomerism, don't worry. I'll ensure we do GOC also once again. ठीक है, तो यहाँ देख लीजिए, what we have is ozonolysis happening on a triply bonded system. तो सीधा आप इस तीनों bond को नहीं तोड़ेंगे, you will just break the doubly bonded system and make it into a diketone, right? Polymerization, if we are talking about, there can be linear polymerization as well as cyclic polymerization. Linear is very simple, ठीक है? Linear क्या है? Polythene. और cyclic क्या है? Cyclic है बहुत important. We take 3 molecules of ethyne. We take red hot iron tube. The moment you see red hot iron written, और आयरन ट्यूब विद द हीट वाला ये जो ट्रायंगल बनाते हैं दिस रिटन, और सिंपली रेड हॉट आयरन ट्यूब फुली रिटन, थिंक ऑफ बेंजीन्स फॉर्मेशन. सो वी एंड अप गेटिंग इन द प्रेजेंस ऑफ red hot iron tube 873 Kelvin, we end up getting benzene, right? Now guys, we are ready for aromatic hydrocarbons. Preparation आप समझ ही चुके हैं. We have done 2 preparations already while I was teaching you number 1 from hexane by adding vanadium oxide, molybdenum oxide, or chromium oxide, if you remember, in the presence of alumina, high temperature conditions, high pressure conditions was giving us benzene. We remember? Of course we do. And second आपने अभी किया from 3 molecule of ethine, right, in the presence of red hot iron tube, high temperature conditions, you end up getting benzene. Okay, now let's see, from alkyne, do we already know this reaction? Of course we do, we've just done it. If we are taking N-heptane, that will produce toluene. Absolutely right, Manav. But make sure N-heptane in the presence of chromium oxide, vanadium oxide, molybdenum oxide, high temperature and pressure conditions. Right? ठीक है? So आदर्श ने पूछा है what is GOC और फिर कह रहे मैम प्लीज रिपीट. तो भाई तेरे लिए तो रिपीट नहीं होने वाला है, ये तो 100% है. GOC जो पूछ रहा है उसके लिए रिपीट तो नहीं कर रही मैं. ठीक है, अब करते हैं फ्रॉम एरोमेटिक सिस्टम बेंजीन विद COONA. अगर इस तरीके का है, and you know already about the soda lime process, you already know about decarboxylation, you already know about the trick to go about decarboxylation. You take up the acid that is there, the acid that I am talking about, not the sodium salt of acid, I'm just talking about the acid. Like benzoic acid will be the acid here, concerned acid. If you remove this H plus, then you get the sodium salt of benzoic acid. So what you have to remove is CO2, that's it. Decarboxylation means CO2 निकालना है. ठीक है, what you end up getting, CO2 निकाला तो यहाँ पे हाइड्रोजन ही तो बचा. So pentanone, what is ready is benzene, right? Now the next one is from phenol. Okay, from phenol, very simple. This is again the conglomeration of 2 chapters together, alcohol, phenols and ether. में भी आप यही वाला reaction करते हैं. Here also, so we have phenol in the presence of zinc gives you benzene yet again. ठीक है? ठीक है. Now chemical properties, electrophilic substitution as well as addition reaction. How to remember? लक्ष्य, मेक श्योर जो पढ़ते जा रहे हैं उनके शॉर्ट नोट्स बनाते रहिए. ठीक है, जैसे अभी हमने बेंजीन किया, बेंजीन के हमारे पास 3 प्रेपरेशन है. पहला हमने किया फॉर एग्जांपल फिनॉल के साथ बाय एडिंग जिंक. दूसरा लेट्स से हमने किया बेंजोइक सोडियम सॉल्ट और बेंजोइक एसिड के साथ. तीसरा हमने किया इथाइन के साथ 3 मॉलिक्यूल्स, राइट. फोर्थ वी हैव ऑलरेडी डन फ्रॉम एन हेक्सेन. सो you have to systematically write them down. There is only a way to use your visual apparatus, your speaking apparatus all together in order to master this. सिर्फ हवा में बात करोगे कैसे करे से नहीं होगा काम, करना पड़ेगा, right? ठीक है. Now guys, let's talk about the electrophilic substitution. 5 reactions are very important here. The nitration, the sulfonation, the halogenation, the Friedel-Crafts alkylation, the Friedel-Crafts acylation, right? So guys, here when I'm talking about electrophilic substitution, is the mechanism important? Mechanism is very important. क्योंकि कुछ गड़बड़ होती है यहाँ पे. गड़बड़ क्या होती है? We have here benzene, which is aromatic, and we have to do the electrophilic substitution, which is not very easy. At the place of hydrogen, you are making an electrophile come and sit. So first step, you must generate electrophile. The second step should be the electrophile के ऊपर attack, which is the most important step. It is the rate determining step. It is the slowest step because here there is a loss of aromaticity. Only what is present is extended conjugation, that's it. Aromaticity is gone. We call it arenium complex. So we get an arenium complex where there is no aromaticity. But this is not long sustaining. Long sustaining नहीं है. दोस्त का बर्थडे था अगले दिन, उसके अगले दिन बोर्ड का एग्जाम था, दोस्त ने बुलाया कि यार पार्टी करते हैं आज रात को, आजा. You go there, you have a party, and then when you come back, you're filled with guilt. You're filled with guilt that अरे यार इससे अच्छा पढ़ ही लेता, अब मुझे कुछ नहीं आता. So what you try to do is you try to compensate the very next day, right? It's not a long sustaining guilt. You overcome that by studying harder. Here also there is a guilt that aromaticity, which is the most important stabilizing factor, is gone. But we need to regain stability, so that's why the third step, where aromaticity is regained by the loss of proton. So this goes and hence the electrophilic substitution takes place, right? So electrophile कौन से हैं जो आपको याद करने हैं? If you have halogenation Cl plus, Br plus, depending on what kind of halogenation you're doing. अगर nitration है तो NO2 plus. Friedel-Crafts alkylation है तो हमारे पास CH3 CH2 alkylation, so there must be an alkyl carbocation, a stable one. Acylation है तो acylium ion CH3CO plus. And अगर आपके पास sulfonation है, the only place where you have a neutral electrophile, SO3. Okay, so guys, here all 5 of them should be on your fingertips, where we have halogenation, where we have nitration, sulfonation, Friedel-Crafts reaction. Electrophiles must be in the realm of your mind. Cool? अब आप देख लीजिए सब्स्टिट्यूशन किस तरीके से होता है. एग्जाम्पल, अगर क्लोरीनेशन इफ यूर डूइंग, क्लोरो लग जाएगा इन द प्लेस ऑफ हाइड्रोजन. इफ यूर डूइंग नाइट्रेशन, NO2 लग जाएगा एट द प्लेस ऑफ हाइड्रोजन, राइट. अगर आप सल्फोनेशन कर रहे हैं, H2SO4 इन द प्रेजेंस ऑफ, और H2SO4 conc, लेट मी राइट, तो लग जाएगा SO3H. क्या है इलेक्ट्रोफाइल? SO3. Finally, SO3 accepts one of the H plus to become SO3H. ठीक है. अगर हम बात करें Friedel-Crafts acylation की, तो COCH3, let's say if to the benzene I add CH3, COCl in the presence of AlCl3, I get COCH3. Similarly, if I add to it CH3, CH2Cl in the presence of a Lewis acid like AlCl3, I end up getting CH2CH3 here, right? So electrophilic substitution is happening at the place of hydrogen, something else is sitting, right? Clear? अब चलते हैं आगे. Look at this. If we are talking about the last one, electrophilic substitution, all of them takes place in the 3 steps. The generation of electrophile, that should be on your fingertips. The second one is the attack of the electrophile, and the third one is the loss of proton. पांचों बातें एक साथ. ठीक है. Now guys comes the addition reaction, where if you are adding hydrogen in the presence of nickel and heating, you get cyclohexane. And if you're adding chlorine in the presence of UV 500 degrees Celsius, 500 Kelvin, you end up getting hexachlorocyclohexane. The easiest reactions possible. All is well that ends well. So here, with this, all the important reactions which are a part of hydrocarbons is all done, all set, right? With this, we've come to the end. We will be taking up all important topics, but if you have a demand, you can drop your comments that, ma'am, we expect this particular topic to be taken. And of course, we personally look at all the comments. I will look at it and we will ensure that we keep a chapter session on that particular topic, whatever you ask for. But yes, the final thing that I would like to say is, आप अगर पूरा का पूरा सेशन अपने हाथों से लिख लेते हैं, all the important reactions has been taken. Trust me, you get a godly vision. If you're serious about studies, you would understand how authentic and how clear the sessions that we are designing for you are. And it gives us happiness that when we are doing some hard work and it gets reflected by your intentions of understanding and learning and absorbing the concepts. Nothing is ecstatic for us. So make sure you make your sessions, your time purposeful. With this, I sign off. The next session is tomorrow, guys. Whatever we have learned, previous year questions based on today's session. So with this, I sign off. Take a good care of yourself. Good night.